Parameters can be thought of as a variable whose value is controlled by the end user. This can be something like choosing a cutoff value for an analysis, or even which field is displayed in a viz. Let's say we want to build a single chart that will be used by two different groups of people, one who are interested in sales and the other who are interested in profit. We only want to make one view, but let the person using it choose what value they want to see. The overall process is easy. Create a parameter to let us select which measure we want to use. Create a calculated field to tie that parameter to the data source. Use the calculated field in the view. Show the parameter control. First, we'll create the parameter itself. Right-click in the data pane and select Create Parameter. We'll name this Sales or Profit. For data type, select String. This will allow us to enter text values. For allowable values, choose List so we can type what we want. Now we'll enter the fields we want to use. Enter Profit and hit Enter. Note that the Display As automatically updates to the same value. We need to remember exactly what we put for the value. We'll need it later. In the next row, we'll type Sales. And click OK. Now we have the parameter, but it doesn't do us any good because it's not impacting anything yet. We need to create a calculated field using the parameter's input. Right-click in the data pane and select Create Calculated Field. We'll name this Sales or Profit. Because we need to go through several options for the parameter's input and assign each to a specific field, we'll use a case function. We could also use if. First, we'll type case, then drag out the parameter. Type when, then type the first value in quotes, profit. This has to match exactly what we put in the parameter value field, and remember, it is case sensitive. Next, we'll type then, and then drag out the profit field. Repeat with the next value. When sales, then sales. And finish with end. Essentially what this does is tells Tableau, when the parameter says profit, give me profit. When the parameter says sales, give me sales. So now we have a field that we can use in the view that responds to the parameter. Let's add this to the viz. We can drag sales off the columns shelf and bring out our new sales or profit field instead. We're now using a field that will show either sales or profit, but how do we change between those options? Right-click on the sales or profit parameter and select Show Parameter Control. The viewer can now change the parameter, and the view will update. A common need in analytics is to determine the date a second event happens. When a customer made a second purchase, a student was absent for a second time, etc. In Tableau, this is achieved using level of detail expressions. For this video, we want to answer the question, what percentage of customers made a second purchase within 6 months of the first? To evaluate, we need to break it down into component parts. We need to know the first order date. We need to know the second order date. We need to determine if the second order date is less than 6 months out from the first. And finally, we need to determine the percentage of customers for which that condition is true. To determine the first order date, we'll use an LOD expression. For each customer, we want the earliest order date, or in LOD syntax, fixed to the level of customer ID, we want the minimum order date. Right-click in the data pane and select Create Calculated Field. We'll name it First Order Date And the formula will be fixed customer ID colon minimum of order date. If we bring first order date to our table, set it to be exact date, and change it to be discrete, we'll see that for each customer, it's repeating the date of the earliest order across all rows. This is exactly what we want. The second order date is a bit trickier. Essentially, what we need to do is look at each order date for each customer and determine if it happened after the first order date. And of those orders, we want the minimum. So we'll create a new calculation, and we'll write it slightly out of order so it matches how we think about it. Is the order date after greater than the first order date? If so, we need that date returned to us so we can keep using the value. So we'll type if order date is greater than first order date, then we want the order date. And we'll close with end. This will return a value for all orders after the first one. We only want the earliest of these, which would be the second order date. So we'll wrap this entire expression in a minimum. And don't forget the parentheses. But we want this recalculated for each customer. That's where LOD expressions come in. We want this minimum per customer, so we'll fix it to customer ID. Let's name this second order date, and we'll bring it out into the view. Again, we want it to be the exact date and discrete. This is just for our viewing purposes for the video. For customers with only one order, second order date is null. For customers with additional orders, the second order date is repeated for each row. This is perfect. Now that we have both the first and second order date per customer, we could be done. But our original question involved how many of our customers made repeat purchases within 6 months. To solve that, we'll need to compare our dates. Create a calculated field, and we'll name it months to second purchase. To find the difference between two dates, we'll use the dateDiff function. First, we need to tell Tableau what date part we care about, days, years. In this case, we want months, and the word month needs to be set in quotes. Then a comma, then our first date. We'll drag out first order date from the data pane. Then another comma, and we'll drag out our ending date, or second order date, and close the parentheses. If we bring months to second purchase to columns, we'll see that many of our customers take far longer than 6 months to repurchase. But this is just a small subset of the data, so let's keep going. Let's build a calculation that will bucket customers for us. We want to know if they did not make a second purchase at all, if they made a second purchase within 6 months, or if it took longer than 6 months for the second purchase. We'll create a calculated field, name it Repeat Purchasing, and we'll enter, if months to second purchase is greater than 6, then more than 6 months. Else if months to second purchase is less than 6, then within 6 months. Else, no second purchase. And we'll finish with end. If we bring this calculation into the view, we see, yep, it's working appropriately. Now we're fully set up to answer our original question about what % of customers purchase again within 6 months. Create a new sheet, bring repeat purchases to rows, and right-click drag Customer ID to Columns, and select Count Distinct. Now we see the raw numbers of how many customers fall into each of these categories. If we bring up the Pills drop-down menu and add a quick table calculation for percent of total, and turn on Mark Labels, we see that, oh dear, only 8% of our customers make a second purchase within 6 months, and a whopping 68, almost 69% don't purchase again at all. Clearly, we have work to do. Here, our primary data source, Global Superstore, only has countries' full names. However, we want to use their 2-letter ISO abbreviations instead. We have another data source, Country Codes, which has both the countries and their abbreviations. We'll blend with Country Codes. The orange link means that our data sources are linked on the field Country. So we can go ahead and bring Country Code into the view. We want to use these 2-letter abbreviations in all of our vises. To do so, we can change the alias of the country field's members. Aliases are alternate names for a specific value within a dimension or for a field itself. We have 2 options for how we want to do our aliasing. Right-click on the country code pill on the rows shelf, and we see Create Primary Group or Edit Primary Aliases. Let's click Create Primary Group. This creates a group for each row of the bar chart. The group AF will contain Afghanistan, AL will contain Albania, and so on. Click OK. And if we go back to the primary data source, we see that a new grouped field has been added. We can now use this in place of our original country field. We'll end up breaking the data blend relationship since it was based on country full name, but we don't need it anymore. The headers show the group's name, giving us the abbreviations. Note that we have not modified our data with this option. The other option, if we right-click on Country Codes pill again, is to edit the primary aliases. This will actually re-alias those members. We're not creating groups here, we're modifying the original field within Tableau. This is essentially an automated way of clicking on each country's header, clicking Re-alias, and entering the abbreviation. It's easy to see how these features of blending to re-alias can save a lot of time and effort, and it's very easy to do. Bollinger Bands are commonly used in financial analyses to see if stocks are under or oversold, using a moving average based on a specific period. The basic principle of Bollinger Bands involves a moving average. Moving averages are calculated over a specific period of time. Here we have a parameter, look-back period, to allow the end user to determine the time period. We can edit the parameter to see that it's an integer, allowing a range from 1 to 50 with a current value of 20. Our date is currently weeks, so our look-back period is the previous 20 weeks. If we change this to days, our look-back period is 20 days. Bollinger Bands have upper and lower limits that are established using a specific number of standard deviations. We have a parameter to set this value to. It's also an integer parameter with a range of 1 to 4 and a current value of 2. Next, we need the 2 core calculations, the moving average itself and the standard deviation. First is the moving average. Let's edit to see the formula. This simply says, compute an average of the average closing price, starting whatever our look-back period is, such as 20 weeks in the past, and coming up to the current value, indicated by 0. For the standard deviation, it's very similar. This calculation is structured exactly the same way as moving average. We use the window average and standard deviation because we want to capture the average closing price and average standard deviation in the view, not in the underlying data. These pieces, the moving average and standard deviation, are used to create the upper and lower bounds. This simply says, from the moving average, go up however many standard deviations the parameter tells you to. The lower bound is the same, just with a minus. To assemble the view, bring moving average to the rows shelf, then right-click and select dual axis. Then bring the upper bound to the same right-hand axis and the lower bound as well. Right-click on the axis and choose Synchronize. Then right-click again and uncheck Show Header. I like to set all parts of the band to be gray. Finally, just like with control charts, we can also use a calculation to establish if the value is outside the band. The calculation is if the average closing price is less than the lower bound or above the upper bound. For the marks card for closing price, if we bring this calculation to color, it will clearly show where the price falls outside the bands. We can edit the colors and show the marks. In summary, to create this view, we needed a moving average and a standard deviation based on the same period as the moving average, upper and lower bands consisting of the moving average plus or minus some number of standard deviations, and if desired, the look-back period for the average and standard deviations can be parameters rather than hard-coded, as can the number of standard deviations. A bump chart is a line chart that shows the change in rank over time. It can easily convey the ranks at the start and end of the time period, as well as changes in ranking over time. Our bump chart will look at profits across the markets in Superstore. Right now, we're looking at actual profit numbers. Making this a bump chart will quickly show the ranks of the various markets. First, right-click on Profit and apply the quick table calculation Rank. Right-click again and change Compute Using to Market. Next, right-click and change the profit pill to Discrete. Make sure the mark type is a line. The dimension doesn't have to be a date, but traditional bump charts do have some sort of order for their dimensions. We can swap month of order date for subcategory, but this doesn't really mean anything because the fact that binders are followed by bookcases is arbitrary. If we do use a date, note that it must be discrete. A control chart is used to establish if variation in a measurement is within acceptable bounds, usually determined by the standard deviation. Control charts are most often done with time series data. Control charts are more complex than some other chart types in Tableau because we have to write a couple calculations. To start, we need to establish the upper bound and lower bound of what is considered in control. This will be determined by the standard deviation and a parameter, which will allow the end user to select how many standard deviations from average they like the cutoff to be. First, we'll build the parameter. Right-click in the data pane and select Create Parameter. We'll name it Standard Deviations, and for data type, we'll choose integer. Allowable values will be list, and we'll enter 1, 2, and 3. Second, we'll build a calculation for the lower bound. right-click, and create calculated field. We'll name it lower bound and enter our calculation. This says, take the average of the marks in the view, that's the window average of the sum of profit part, and subtract the standard deviation, calculated by the window standard deviation of sum of profit, times whatever multiplier is selected in the parameter. A quick note on window functions. We use these because we want to capture the average profit and average standard deviation in the view, not in the underlying data. We'll repeat this for the upper bound. Right-click, select Create Calculated Field. We'll name it upper bound, and enter a very similar calculation. The only difference here is that it's now plus instead of minus. Third, we'll create a calculation to tell us if a given mark is outside of the bounds, which is out of control. Right-click and select Create Calculated Field, and we'll name it Outliers. We'll enter our formula, which determines for each mark in the view, which is the monthly sum of profit, if it's below the lower bound or above the upper bound. Now that we have these pieces, let's assemble the view and build our control chart. We'll bring measure values to rows and keep only the upper and lower bounds. We see our nice lines. We'll right-click on the Measure Values pill and select Dual Axis. Right-click on the right-hand axis and select Synchronize Axis. Then again, and uncheck Show Header. Next, click on the Sum of Profits Marks card and bring Outliers to Color. Finally, right-click on the parameter and select Show Parameter Control. If we want to do some formatting, we can edit the colors so that gray is false and red is true. Click Color again and choose the option to show the marks themselves. If we play with the parameter, we can see that for 2 standard deviations, only 3 marks are out of control. In summary, to build a control chart, we need to establish the upper and lower bounds and a calculation to determine if a given mark is outside of those bounds. Funnel charts are used for analyzing things like how many prospects are in each stage of the sales funnel, or how candidates move through an interview process. This dataset is looking at the number of prospects we have in our sales cycle and what phase they're in. Building a basic funnel chart is easy. We'll bring the number of prospects to the left side drop area and bring phase to color. We now see how many prospects are in each phase. We could manually sort the phase in the color legend, or if we sort descending, the nature of the sales funnel means that it'll sort the phases into the correct order automatically. Next, we can bring number of prospects to size and change the fit of the view to entire view. This will give it more of that funnel shape. That's the basic funnel, though we can add more information very easily. Bringing phase to label can be useful, and if we bring number of prospects to label, then add a quick table calculation for percent of total, we get another piece of useful information. Many funnel charts, though, look a bit more elegant. If we want a smoother funnel chart, we can do so by using a different mark type. This time, we'll bring number of prospects to columns and phase to rows. We'll sort descending again and change the mark type to area. Again, we'll change our fit to entire view. And aha, there's a bit of that funnel shape. We only have half of it, though. To easily make the funnel symmetrical, we'll simply create a calculation for negative number of prospects and use that to fill in the other side of the funnel. Right-click on Number of Prospects and select Create Calculated Field. We'll name it Negative Number of Prospects, and then simply type a minus sign at the beginning. If we bring this field to the left of the columns shelf, we see the classic funnel. We can do a couple things to tidy the view, but the meat of the chart is done. I like to hide the headers and format the borders to not have a column divider. Then bring Phase to Label, but we'll do it just for one side. And for the other side, we'll bring Number of Prospects to Label as well, and again make it a % of total. There's our funnel chart. Line graphs are a wonderful way to show data over time, but if the data is only captured at discrete points in time, drawing a straight line between those points could be misleading. Data often doesn't change in a gradual, continuous manner, but rather makes a jump from one discrete value to another. Let's look at how we can plot this in Tableau. Building a line graph in Tableau Desktop is straightforward. Here, we have data on best-selling books. We're filtered to just the trade paperback fiction list, and we're looking at one single book, Ready Player One. Let's build a timeline for the rank of this book over time. We'll start by bringing week to the columns shelf. By default, this comes out as a discrete date part, starting with year. But we want a continuous line across time, so we'll change this to be a continuous week by using the drop-down menu and selecting week number in the second section here for date truncations. Now we see the span of the dataset, about 4 months. Next, we want to see rank over this time span, so we'll bring rank to rows. The mark type is automatic, and we can see that it's a line. We could also force it to be a line by manually setting the mark type to line in the dropdown. Because a rank of 1 is better than a rank of 15, I want the axis to be switched so that 1 is at the top. Right-click on the axis and select Edit Axis, then check Reversed for the scale. Now we have this timeline graph, and we can see there have been some ups and downs, but the book peaked at number 1 right about the time the movie came out at the end of March. But did it gradually move from rank 3 to rank 1? No, it was ranked 3rd for 1 week and ranked 1st the next in an abrupt shift. A better way to show this data might be to use step or jump lines. Unlike a regular line graph, which plots each value, then draws a straight line between a set of points, a step line plots the value until it changes, then, like a staircase, shoots up or down to the next value at a 90-degree angle. This can be very useful for emphasizing the magnitude of the change. A jump line does a similar thing, but it doesn't draw the vertical line connecting the values. It jumps from one to the next. This can be useful for emphasizing the duration of a value before it changes. To change the line type between linear, step, and jump, click the Path shelf on the Marks card and select the desired type. The value markers can be toggled on or off by clicking the Color shelf and selecting the desired option. A Pareto chart is used to see how many dimension items, such as products, are contributing to what percentage of an overall measure, such as sales. Pareto charts are often used in conjunction with the 80-20 rule, which states that 80% of sales come from 20% of customers, or 80% of value comes from 20% of content, etc. To make a Pareto chart, we'll use table calculations to compute the percent of total of the running total for both the measure and the count distinct of the dimension. Our Pareto will deal with products and sales. We'll bring product ID to columns and choose Add All Members, dismissing the warning. we'll bring sales to rows, sort sales descending, and we'll fit the width. Next, we want to calculate the running percent of total sales. Right-click on the sales pill and add a quick table calculation for running total. Right-click on the same pill again and select Edit Table Calculation. Click Specific Dimensions and verify that Product ID is checked, making this an addressing field. We'll check the box to add a secondary calculation, and for the type of secondary calculation, we'll choose percent of total. Now we need to change the x-axis from a sorted list of product IDs to display a percent of total as well. Control-click to drag a copy of the sorted product ID pill from the columns shelf to the details shelf. Right-click on product ID on the columns shelf and change the aggregation to Count Distinct. We'll now do the same thing we did for sales, calculating the percent of running total. Right-click and add a quick table calculation for running total. Edit the table calculation. Verify that Specific Dimensions has Product ID checked. And add a secondary calculation for percent of total. Finally, we'll change the mark type to a line. This is the core of a Pareto chart. A true Pareto chart has both the line as well as a bar chart. To add the bar chart, we'll bring a new copy of sales to the rows shelf. Right-click on this copy of sales and choose Dual Axis. On the marks card for this sum of sales, we'll change the mark type to be bar, and we want to size the bars to be manual and pretty tiny. Right-click on the right-hand sales axis and select Move Marks to Back, and then again to uncheck Show Header. Let's change our colors so our line is blue. Finally, we can add a reference line to illustrate the 80-20 rule. Click on the Analytics tab and bring out a constant line to the distinct count of product ID and enter 0.2. Bring out another constant line to the sum of sales with the table calc, indicated by the delta, and set the value to 0.8. As we can see in this dataset, we need closer to 28% of our product IDs to get 80% of our sales. As a quick recap, to make a Pareto chart, use table calculations to compute the percent of total of the running total for both the measure and the count distinct of the dimension. Bring a new copy of sales out and make it a bar chart underneath the line. And add reference lines for 20% of the dimension, it's count distinct, and 80% of the measure. A waterfall chart shows the running total of a particular measure, usually with positive and negative values, over a dimension. It shows the relationship of each dimension member against the running total. That is, how each member is contributing to the overall total, either positively or negatively. To create a waterfall chart, let's start with a basic view, profit over time. First, we need to change the measure to be a running total. Right-click on the profit pill and add a quick table calculation, running total. Note that the default chart type here is a line. The second step is to change the mark type to Gantt. This draws a line at the value of each month's running total of profit. Next, we'll size each mark by negative profit. This essentially stretches each Gantt bar's height to line up with the start of the previous bar. Note that negative bars need to grow upward and positive bars need to grow downward, which is why we need negative profit. So the third step is to create that calculated field for negative profit. Right-click on Profit and select Create Calculated Field. Enter a minus sign in front of profit, and we'll name the field Negative Profit. Fourth, we'll bring negative profit to size. And fifth, bring profit to color. To summarize, a waterfall chart is made by having a measure displayed over a discrete dimension, and we apply a running total quick table calculation to the measure, change the mark type to Gantt, and size by the negative of whatever our measure is.